Here's your 2026 AB Calculus number one, which is almost always a calculator question. Male birds arrive. Okay, so male birds are arriving, and this is how many birds per day. Okay, this is the classic. Here's the table, and then interpret that. M prime is 7.5. Now be careful with what you're looking at. We see this is M, and this is M prime. All right, so the average rate change of M. So this is the instantaneous rate of change. The average rate of change can approximate it. So we need 7.5, which is halfway between those two. Okay. So for part A, we're just going to say M of 10, right? Minus M of 5. Why 10 and 5? Because 7.5 are halfway between. So M of 10 is 16 minus 7 over 5, 9 over 5. Be careful, indicate units of measure. This is birds per day squared, or birds per day, because remember, this is M. M is already birds per day. M prime would be birds per day. Part B, use a midpoint. Okay, they haven't used midpoint here lately. They've been used a lot of rights, sometimes left, sometimes trapezoidal, but we're going for midpoint. Okay. So that's a little different. From 0 to 10, that's the orange box. 10 to 20, purple box. 20 to 30, black box. Okay. So this is to approximate this. It's approximately, so the gap is 10. We're using the midpoint. So it's 7. So 10 times 7. And then for the purple, we're using the 6 halfway. So 10, that's the distance between 10 and 20 times that halfway point is 6. And the black one, 10 times 2. And just add all those up. That's going to be 150. And what does that represent? Okay, so remember when you take so 150s B, there's that. This is the answer to A. So for part 2, so remember when you take the antiderivative of the rate of A rate, that's accumulation. So we have accumulated, there's approximately 150 birds have arrived day 1 through 30. That's 2. All right. We'll need some rooms if y'all get that. That's approximately. All right, so next up, part C. So here's where we need I need Desmos, right? Go get a Desmos going right here. Desmos. Oh, looks like I already had a tab. Oh well. So no females at all, days 0 through 15, so none at all. And then but 15 to 45, they start arriving. So F, I'm just going to say, for my reference, I'm just going to say little f of x equals, I'm going by memory here, so it might be wrong, 18 plus 16, I think is what it said. If not, I'll fix it. Sign, let's see, parentheses, such pi, pi, sufficient, pi divided by, where are we at, divided by 20, press to the right. I'm going to say x, I know it says 10 there, I'm going to say x. X minus 15, I think that's right. Let's see how I did. 18 plus 16, oh, it's plus. That's plus. My bad. Okay. Plus up there. So that's what we look like. 18 plus, okay. So what to do with that? Blah, blah, blah. How many female birds arrive? Okay, so that's just accumulation. INT, 15 here, 45 there. F, obviously, to take the AP exam, we better know how to use Desmos, especially the derivative and integral functions dx. Okay, So it looks like about 642 birds or so, 642 to the nearest 18 plus 16. Let me make sure one more time I have that right. Sine 18 plus 16, sine pi over 20, x plus 15. Sine of, okay. So 642 birds. So I would write there for part C, I would put this f of t dt, 642 birds. Part D on the interval 15-30, the difference in the rate of the species arrived in the nesting area can be modeled by the differential function. Rid of this. M of t minus f of t, where f is a function. Fine. Is there a time when d of t equals 0? Okay. So from 15 to 20. So we need to figure out, let's see. So let's figure out what is d of 15. This sounds like an intermediate value theorem, doesn't it? It sounds like it. So we need these things to be continuous. D of 20. Remember, the mean value theorem is that the average rate of change equals the instantaneous at somewhere in the interval. But the intermediate value theorem just guarantees the existence of a value. You essentially just can't skip over stuff. So let's figure out these two things. M of 15, that's going to be from our table. Gosh, I'm going to have to look over here in this other paper. What is, kind of shrink it. This crazy thing that I have won't let me zoom back and forth. Let me look over here just a second. D of 15 is 6. Sorry, M of 15 rather is 6. Sorry, I just look at another. I didn't want to have to erase this. F of, oh God, I got it too anyway, because I've got to go back and forth. I got to figure out a better way to do this. So I need to go to, so 6 and 5. Let's just remember that 6 and 5. Okay. So I've got to go back to here to get my F of 15 and F of 20. All right. F of 15. So I wasted that time for F of 15. All right. And F of 20. Okay. So F of 15 is 2. F of 20 is 6.68. 16. Okay. So that means, let's just take D of 20 would be 6, or D of 15, excuse me, would be 6 minus 2. It's 4. Well, we know that without having to type it in. And then 5 minus 6.68. So just to clarify what this is M of 15 minus F of 15. This is M of 20 minus F of 20. Okay. And you can see that there is a transition as we go from 15 to 20. There's a transition from positive to negative. So yes, we would say something along the lines of M, that D of T must be 0 since 0 is between, it's actually less than D of 15, but bigger than D of 20. And D is continuous by the IBT. Yeah, so that's part D on that. Okay, so that's number one. Not too bad. It's usually pretty mild.